Dear students, this lecture deals with the second set of parameters known as Y parameters. Okay, so what do you mean by Y parameter is that it is actually the parameter that is giving you the ratio between current and voltage at different points. Okay, that is why it is known as Y. Y means admittance. So actually Y parameters are known as short circuit admittance parameters. Okay, Y parameters are known as short circuit admittance parameters. The designation of admittance is actually Y. So short circuit admittance parameters or Y parameters is the ratio between current and voltage. So actually the equation that are representing Y parameters are I1 is equal to Y11 V1 plus Y12 V2 and I2 is equal to Y21 V1 plus Y22 V2. So the Y parameters are Y11, Y12, Y21 and Y22, and here we are representing the currents, that is I1 and I2, in terms of V1 and V2. So in matrix form I can write the current vector I1 I2 is equal to the matrix Y11 Y12 Y21 Y22 into the voltage vector V1 V2. So this is a matrix representation of the Y parameter. Now how we can find the parameter values of Y11, Y12, Y21 and Y22 is that you are making any of the ports as short circuit. Short circuit in the sense the voltage across that port is equal to 0. Okay, so if you are making V2 as equal to 0, that means from these two equations, if I am making V2 as equal to 0, that means if I am making V2 as equal to 0, I am getting I11 as equal to Y11 V1 and I2 as equal to Y21 V1. Okay, so from the first expression Y1 is equal to Y11 V1, I can solve for Y11 as equal to I1 by V1. And from the second expression I2 is equal to Y21 V1, I can represent Y21 as equal to I2 by V1. Okay, similarly, if I am making the input port as short circuit or V1 as equal to 0, I can write I1 as equal to Y12 V2 and I2 as equal to Y22 V2. So from the first thing, I1 is equal to Y12 V2, I can solve for Y12 is equal to I1 by V2, and from the second expression I2 is equal to Y22 V2, I can write Y22 is equal to I2 by V2. Okay, so these are the values of 4 parameters if any of the ports are short circuited. Okay, so the syntax also like suffixes are also like this: Y11 indicating that it is a ratio between current and voltage I and V, 11 indicating that I1 by V1, or Y21 indicating that I2 by V1. Okay, so these are the expressions corresponding to Y11, Y12, Y21 and Y22. And here Y11 is a ratio between I1 and I2, therefore it is known as the input admittance or short circuit admittance at the input side. Okay, Y11 is known as a short circuit input admittance. Now Y12, what is Y12 is that Y12 is the transfer admittance at port 1 due to port 2, or it is a ratio of the current at port 1 to the voltage at port 2 when port 1 is short circuit, is known as transfer admittance. Similarly, Y21 is also the transfer admittance of port 2 to port 1, or it is known as the ratio of the current at port 2 to the voltage at port 1 when port 2 is shorted. And Y22 is known as the short circuit output admittance because it is the ratio between the output current and output voltage. Okay, so these are the Y parameters. So here why it is known as short circuited admittance parameter is that for finding the values of Y11, Y12, Y21 and Y22, we are making any of the terminals as short circuit. That is why it is known as short circuit, and we are making the ratio, we are finding the ratio between current and voltage. So that is why it is known as short circuit admittance parameter. If you are making V1 as equal to 0, I will be getting Y12 and Y22. And if I am making V1 as equal to 0, V2 as equal to 0, I will be getting Y11 and Y21 as shown here. Y11 is I1 by V1, Y21 is I2 by V1, Y12 is I1 by V2, and Y22 is I2 by V2. So these are the Y parameters. So the names are Y11 is short circuit input admittance, Y12 is short circuit transfer admittance from port 1 to port 2, and Y21 is short circuit transfer admittance from port 2 to port 1, and Y22 is short circuit output admittance. These are the names of the Y parameters. And the equivalent circuit representation of the Y parameter is like, you will be having the equation I1 is equal to Y11 I1 plus Y12 V2, sorry, not I1, V1 plus Y12 V2, and I2 is equal to Y21 V1 plus Y22 V2. So these are the equations corresponding to Y parameters. So here you know that this Y11 V1 is actually representing a current. Voltage into admittance will give you the current. And here this is also representing a current. This is also representing another current, and this is also representing another current. So I1 is a sum of two currents. So I can take like, if this is the input terminal, this is the input terminal, I am having the current I1 here, and if V1 is the voltage that is applied across this terminal, then if I am having an admittance equivalent to Y11, then the current flowing through this will be what? Current flowing through this particular path will be V1 into Z11, since V1 is a voltage at this particular node. Similarly, you have the second term, that is actually a current that is depending upon the voltage V2 that is at the output side. So we can represent that as a dependent current source that is delivering a current equivalent to Y1 to V2. Okay, so that is a representation of the input side. In the output side also, we will be having two terms, one corresponding to the current and second corresponding to second current. So here we know that V2 be the voltage at the output port and I2 be the current that is flowing through the output port. That I2 is a sum of Z11 V1 and Z22 V2. So V2 we know that it is a voltage across the second terminal itself. So if you are connecting an admittance equivalent to Y22 here, then the current flowing through that particular Y22 will be Y22 into V2. But what about the second term? The first term is Y21 into V1, that is depending upon the input voltage V1. Therefore, that can be represented as a dependent current source that is delivering current equivalent to Y21 V1. So this is actually the equivalent circuit, equivalent network, or equivalent circuit of a two-port network in terms of Y parameters. So in terms of Z parameters, we are taking voltage sources, and in terms of in Y parameters, we are taking current sources. Okay, so this is the equivalent representation of the two-port network in terms of Y parameters. Okay, so that's all with Y parameters. Now we have to study about the condition for reciprocity and symmetry in terms of Y parameters. So what is the condition for reciprocity is that, so you learn about the reciprocity condition of the Z parameter. We know that a network is said to be reciprocal if the ratio of excitation at one port to the response at the other port is same if excitation and response are interchanged. So here also we are taking the same conditions. I am taking case 1. Like I have the network, I am connecting my excitation at the input side, that means the source is connected at the input side, and I will be taking the output from the output side. Let this be I2 dash, this be I2. So hope you are remembering about the Z parameter. So this is a two-port network. If this is the case, here also I can write my V1 is equal to Vs itself, since there is no resistance between the paths, and my V2 is equal to 0 since there is short circuit, and my I2 is equal to minus I2 dash. Okay, so if we are substituting these in my equations, I have the equation as I1 is equal to Y11 V1 plus Y12 V2, and I2 is equal to Y21 V1 plus Y22 V2. So this, from this equation I can write I1 is actually not given, but minus I2 dash is there. So from this equation I can write my second equation. From second equation I can write my I2 dash is equal to Y21 into what? Vs. V2 is not there, so my I2 dash is equal to y21 into v2, or minus I2 dash is equal to y21 into vs.